Okay, question number 21, page 153. The question is, if y equals sine squared of 3x minus 2, what is dy dx? So, let's think about what the chain rule tells us to do on this. If we were putting a number in for x, say 5, we would take 3 times 5 minus 2. We would take the sine of that number, and then we would square it. The last thing we did was square it. That's our outside function. That's f. The fact that we square it. What did we do right before we squared it? We took 3 times 5 minus 2. We took the sine of it, and then we squared it. The sine was the thing we did right before we squared it. That's our function, sine. But that's not all we do is take the sine of it. We take the sine of it after it's been changed, 3x minus 2. There's a third function here. There's an inside function, 3x minus 2. Okay, so f prime, g prime, and in this one we have a third function, h prime. F prime, the derivative of x squared, is 2x. G prime, the derivative of sine, is cosine. H prime, the derivative of 3x minus 2, is 3. But now what does our chain rule look like when we're dealing with this much stuff, this many functions? Not just f and g, but f, g, and h. Well, it still starts the same. It's still f of g. 2 times, and then we plug g in for f. But it's not just g, it's g of h. F prime of g of h. So h gets plugged in to g here, like that. Okay, the next thing we do in the chain rule is multiply by g prime. But it's not just g prime, it's g prime of h. And now we have to multiply it by h prime. And there's our answer. 2 times the sine of 3x minus 2 times the cosine of 3x minus 2 times 3. This was f prime of g of h times g prime of h times h prime. So you can imagine what would happen if there were 4 functions, say f, g, h, and k. You would have f prime of g of h of k. Then you would have g prime of h of k. Then you would have h prime of k. And then you would have k prime. The important thing to remember is that every one of your derivative functions, f prime, g prime, h prime, however many there are, every one of them is going to get used once. And all of the original functions will get used over and over except f. F never gets used. F prime of g of h of k of l of m and n, however many there are, you go from here down to there and then just go down. G prime, go over to h and k and l and m, however many there are. H prime, if there are any more over here, we keep going down, and you just keep repeating that over and over. Alright, so there it is. 2 times the sine of 3x minus 2 times the cosine of 3x minus 2 times 3. If we wanted to write that like an amplitude out front, the 2 and the 3 we could combine together and call 6. And then we've got the sine of 3x minus 2, the cosine of 3x minus 2, and we're set. Alright, well the book says if you are unsure of your answer, use n-deriv to support your computation. In other words, let's have the calculator verify for us what the right graph looks like. So let's do that. Our original function was sine squared of 3x minus 2. So the sine of 3x minus 2, and then I need to square that. Whoops, I need a parentheses out front here, don't I? Okay, so this parenthesis to that parenthesis there are saying take the sine of this, and then after you're done with that, square it, which is what we want, sine squared. Alright, and so we can graph that. I'm going to do a zoom trig since it's a trig function. And it looks something like that. Okay, great. Now we can have the calculator do the derivative function for us by doing math. Number 8 is n-deriv. I want that function, so I'm going to, instead of typing that whole thing again, I'm just going to use y1. And then we have to put the x in, and then instead of putting a number in, we're going to put another x since we want it to do it for all values of x. And we'll graph that. Okay, there's the first function, the little humps here, and then here's the second function. Also humps, but they're much taller, because now it's graphing the slope. Now the slope might be steeper than the actual value of the function. So there it is. That one takes a while to draw because the calculator's got to calculate every pixel and then connect the dots. So that takes a little bit of time, but not too bad. Okay, so this one here that zigzags up and down with an amplitude of 1, that's our original function, that's y. This one that's got an amplitude of, it looks like about 3 or 4, that's tall one, that's our derivative function. What we want the calculator to do is give us a good feeling that our answer, which was 6 times the sine of 3x minus 2 times the cosine of 3x minus 2, that is the same as this. So I'm going to turn off y2. I'm going to turn off that derivative graph. And what I'm hoping is that this graph in y3 looks exactly like the one that I just turned off. We'll see if they're the same. There's y1, that's our original function. It's not going to graph y2. There's y3. The fact that this new graph looks exactly like the one that I turned off, the n-deriv graph, is what makes us feel like, yes, we did it correctly. If this graph hadn't looked exactly the same as the n-deriv graph, we would say, I probably did something wrong. Okay, so if you got that, good work, and that's the last homework problem for the day, so that's awesome.